In this video, we're going to be discussing limits to infinity. If you had enough fun with a finite number in the past video, there's some more fun for you here with limits to infinity. We want to go ahead for this one and evaluate the following limits. The limit as x approaches negative infinity of g of x, and the limit as x approaches infinity of g of x. So we've got both the left or negative infinity and also positive infinity. I shouldn't say left or right hand limits because we're not doing those. Those don't exist for negative infinity or infinity. Can't go to the left or right of infinity. It's just a concept. And g of x is listed over here. One thing that we can do to graph this is we can go ahead and factor the top. And if you factor this, you're going to pull a 3 out. So that's 3 times x squared minus 9, I think, and we can further factor x squared minus 9 as x plus 3, x minus 3. And in the denominator here, we could, let's see, we could factor this one to be, I think we've got x minus 2, and then x minus 2. Of course, you could write this as x minus 2 quantity squared. It looks like for this one that we don't have anything in common between the top and the bottom. So the value of x minus 2 is equal to 0, or x is equal to 2 in this case, will make the denominator 0, and it's not a point discontinuity, it's not a hole. It's definitely going to be a vertical asymptote. So if we're graphing this, we need to go over here to the graph, and we could draw an asymptote here right at 2. Another nice thing to do is to figure out maybe what any of the x-intercepts are. So to find the x-intercepts, we're going to plug in 0 for y, and we really only need to look at this top part. We can set the top part equal to 0. So we've got 3 times x plus 3, x minus 3, and if you solve this, you would find that x could be negative 3 or positive 3. So we can go to our graph, we can go negative 3 here, and also positive 3. We can look in one other area, and if we go back here and look at our horizontal asymptote, we can see we've got an x squared and an x squared on the top and the bottom, numerator and denominator. And if we wrote a coefficient in here, that'd be a 1. And so we've got 3 over 1, or 3. So there will be a horizontal asymptote here at 3. I like to go to my graphing calculator at this point and see what the function looks like. So we can go right to our starting point here and just type in 3x squared minus 27. And that'll be divided by x squared minus 4x plus 4. And remember to include parentheses both in the numerator and denominator. So we'll go zoom 6 here. And once this thing is done graphing, I really like to see if I can do something where the tick marks are evenly spaced, and that actually is going to be zoom 5, or z square, because the tick marks are evenly spaced here. So to get a better look at what's happening with this function, I like to definitely do that. And that's the shape of the graph. Believe it or not, that's what it looks like. And let me see if I can draw this as accurately as I can. Let's see. So that's going to come down, and it's going to get close to that asymptote right there, and that one's going to come up. This one looks like it almost goes straight down, but it's going to get close to this asymptote. And this one actually goes above a little bit, and it looks like we're at maybe 4, 5 or so. 4, 5 would be right up here, and then the graph begins to come down again. So kind of an interesting looking graph. Doesn't really look like the parent function 1 over x too much, but we've graphed it with our asymptotes, and we can see what's happening and with the graph in kind of a more basic fashion. So if we want to evaluate the first limit up here at the very top, the limit as x approaches negative infinity. All this is end behavior or a horizontal asymptote. That's it. So what we're going to look at is we're going to look at the end of this graph, and you can see that the end of this graph rises up to, won't cross in this case, it'll just rise up to a value of 3. So graphically speaking, as x approaches negative infinity, it looks like it's 3. On the right hand, or on the right side, not right hand limit, on the right hand side, the limit as x approaches infinity, or as we go all the way to the right, what is the y value? Again, approaching, not equal to, just approaching. We can see that this function begins to level out, and it will definitely settle out at this horizontal asymptote, which happens to be here at y is equal to 3. So it appears that both of them, the limit as x approaches negative infinity and also positive infinity, happen to be the same value for this one. If we take a look at the graph from the left, let's make a table. Let's go, I don't know, let's go 10,000 right here. And we can say, let's do, not from the left, let's cross that off. Let's do the limit as x approaches, we'll do infinity. And then this one, we'll do the limit as x approaches negative infinity. A little bit backwards from the top here, but I think you'll be able to follow along. And let's do 20,000. Let's do 30,000. Again, we're just getting really big. X is going to infinity, and this is g of x here. And that'll be 40,000 here, and 50,000, and so on and so forth. When looking at this, you can definitely type this into your calculator. It should also already be in y sub 1, but I think a table would be a nice way to look at this in the calculator. So when you go to your table, I want you to go to table set first, which is second window, and you can start at 0 if you'd like. The important part here is the delta table needs to be big at 10,000. If it's not, then you're gonna have to click the cursor 10,000 times if your delta table was 1 for you to go from 0 to 10,000. So we can actually use our table to just kind of skip over all that, and with one click we'll go from 0 to 10,000. Then you can go to your table and you can see those corresponding values, and the corresponding values in your table should be 3.0012. I know that's going to be kind of small on the screen there. And then at 20,000, we've got 3.0006. And then we've got 3.0004, 3.0003, and 3.0002. So it looks like as x approaches infinity, as x gets really, really big, the value of y seems like it's kind of settling down and almost getting close to 3. And remember, for a limit, we want to list just 3. So we could say that the limit as x approaches infinity of g of x is 3. No, it will never get there, but for a limit, we don't care. We just care about what the value is approaching, and it is approaching a value of 3. We can see that also over here on the graph. Let's do the limit as x approaches negative infinity. So we can go ahead and go to your table and just keep clicking back, and we could make this, negative 10,000. We could make this negative 20,000, negative 30,000, negative 40,000, again as x is approaching negative infinity. And we can just enter those values in right from our calculator. And this one looks like it's going to be 2.9988. The next one is 2.9994. I'll put this one out here so you can see a little bit better. 2.9996, that's the value that goes here. And we've got 2.9997 and 2.9998. As x gets more and more negative, as we approach negative infinity, can't really ever get there. It's great because for a limit we don't care. We just care what happens when we approach it. You can see that these values are growing and getting close to a value of 3. So we could say that the limit as x approaches negative infinity of g of x is equal to 3. Algebraically, we can understand infinite limits as being the value that the value that y approaches as x approaches either negative infinity or infinity, and you can think about them like end behavior or horizontal asymptote. So if you can find a horizontal asymptote of the original function, that would be the best algebraic method that I could give you. So if you look at the original function, we've got 3x squared minus 27, 1x squared minus 4x plus 4, and as long as the degree of the numerator agrees with the degree of the denominator, you can simply write the coefficients. So algebraically, the limit as g of x, oops, that's the wrong notation. Let's rewrite that. Limit as x approaches, in this case it's either negative infinity, or it could be the limit as x approaches infinity is just 3 over 1, or 3. And that's all you need to do.